And in today's video we are solving Leetcode 3342 problem number. So in this today contest, right, we are going to see this problem. Today we have seen the Leetcode 3341 problem, which is almost similar to this problem because it is saying the find minimum times to reach a last room 2 and yesterday it was 1. Okay, so if you have gone through my last video study videos, so you have understood how to approach this type of problems, and you have gone through the goal and how we have used the Dijkstra algorithm that we have seen, right? So let's understand what the question is saying here today. Okay, so this problem Leetcode 3342 is saying find minimum time to reach last room second. So there is a statement given and you better pause this video and go through the statement if you have already gone through the statement. So let's continue. So there is a dungeon with n cross m rooms arranged as a grid, and you are given a 2D array move time of size n cross m, where move time at I and j represents the minimum time in a seconds when you can start moving to that room. So you start from the room 0 0 at time t is equal to 0 and can move to an adjacent room. Moving between adjacent rooms takes 1 second for one move and 2 seconds for the next, alternating between the two. So return the minimum time to reach the room to n-1 m-1 means you are going to start like previous problem that we have seen yesterday. Also it is saying that we are going to start from room 0 0 means top right one, and from the bottom left one we have to go, right, the room, and the two rooms are adjacent if they share a common wall either horizontally or vertically, right? So there is multiple examples out there, but we'll go through these examples, right? So first of all, you understand what the problem was saying, right? So you are given a dungeon, means you can say as a grid or maze, right? We have given, okay, and the dungeon grid where each room can only be entered at or after a certain time, and you move between adjacent rooms, alternating between 1 or 2 seconds for each move. So let's find the fastest way to reach the bottom right room, and well, we'll use the modified Dijkstra algorithm. Why? Because we need to process the fastest path that our move cost changes based on the number of steps taken so far, right? And so that first we'll go through the intuitions or the intuition of this program, and we'll go through. Okay, so what I'm going to do, I'm going to recap this problem statement. What is saying that means, first of all, we have given n cross m rooms that is called dungeon or grid, right? So each room, that is I at I and j, let's suppose we have given each room I and j at a room at I and j, and we have to so for each room I and j has a move time, right, I and j, right, at I and j. That tells you that the minimum time when you allowed to move in this room, that room we have given. So you can only move up, down, left, right, because this is grid, right? So this is not given in the statement, but you have to think like that, right? Today I told you, right? So similar thing you have to understand. So you can move up, down, left, right, in the given from the given positions, right? So moving takes time. What second? 1 second for the first move, then 2 seconds for the next, right? Then 1 second again, and again, so on, right? So alternatively, like you start at 0 0, right? We have given 0 0, and at t is equal to 0, at time equal to 0, and we have to find the minimum time to reach the room n-1 m-1, right? Means from the top right corner to left bottom corner, right? So what is the problem intuition is here, right? So this is a variation of Dijkstra algorithm also with a twist. So you have alternately move cost of 1 or 2 seconds, and then 1 and 2 seconds, so on. So each time has a certain each cell has a certain constant, right? So you can only enter it or after its move time, right? So you can enter for each cell has a constant, so that you can only enter uh, at this given time, at a move time at inj, or after the given move at inj, right? So at each step you must take track, you can say, time taken so far. Like, let's suppose we'll take a distance, and so the distance that we have taken so far, that you have to track it, right? So for each step that we will move from 0 to the room, this one, so what you have to do, you have to track the time taken so far, right? So alternatively, between the cost 1 and 2, for each move we have to take, right? And until we have to wait until the move time at inj allowed entry to the next cell. So we will use the priority queue to always process the next most promising cell, means a smallest time that is taken, right? So we'll go through that. Okay, so understand the problem statement that we have given. So we have seen already this problem study, but let's continue today, because study it was answer was coming 6, but today it is 7, right? So 0444 we have given. So the minimum time required is 7 seconds. So when we are at t equal to 4, right, we have to move from 00 to 10, right? From 00, this is 00, right? And if we will come to the 4, right, it will become what, 10, right? So from 00 to 10, how much is time take? So first from 00 to, it will come to this position, right? And this, from this position it will come to sorry 00 to, it will come here, and then it will come here, right? So at t equal to 4, we have come from 00 to 10, or you can directly come to here. So it will take what, t equal to 4. After the this position, he has to come to here, right? So the first move has taken one time, right? Once t equal to 4 we have taken. So next time it will take what, one more second, 1 plus 1 we have to do, right? And so from here to here it will come in the what, so it has taken 4 time, right? 0 to 4. So this come what, 4, then it's come 5, and from 5 to 7 it will come. Okay, so total 7 time is coming. If you remember the study problem statement that I have shown you, the thing implement details, right, where I have explained this part, right? So better you go in that video, study video, and go through that. Okay, so let's continue what is trying to say. So from how it is going to do that, right? So it will come from 0 to 4, and then 4 to this 4, right? So from here it will take 1 second, then it will take 2 seconds, and it will reach to here 7 seconds. Okay, so this is the way we have to move, right? In the grid you have to traverse your movement, and you have to track your seconds that you are using it. Okay, so from here, it was from here to here, it is taking what, it is giving t equal to 4, right? So at t equal to 4, right, you will come here, right? But for that, for the first move it is taking 1 second, right? So how much it will become from here to here, the t is equal to 4, right? And it is taking 1 second, so it will become what, 5 seconds, right? And from here to the here, it will take what, 2 seconds, right? So from here to here it is taking 2 seconds, means from it, if it is 5, then it will become what, 5 plus 2 is 7, so it becomes 7 seconds. Okay, so this is the way we have to implement it, and then we have to go through. Okay, now it's time to understand the, you can say, overview, right? How we are going to do that, right? So we have to define the state that includes the coordinate at a given time, and time to reach there we have to take, right? So we'll store those in the priority queue. I will do the sorting of those things. So that is why we have to go through the algorithm, and we'll understand what we are going to do here. Okay, so the algorithm we are going to use is this Dijkstra algorithm, and we will use the Dijkstra with a custom move, right? So we treat the grid like a graph, and each cell is a node, and you can move in 4 directions: up, down, left, right, that I have already told you. Then we'll but the question is that movement cost alternative takes 1 second or 2 seconds. So each cell at inj has a move of inj value, and the earliest time that you can enter it, and you must wait if you reach a cell before the given move time, right? So we will apply the Dijkstra algorithm where the distance is the earliest possible time, and we can reach the each cell. Okay, so what are the steps we are going to do? So the steps we are going to do, you pause this video, right, and initialize these variables. Okay, I'll say why I'm saying that. You will write the code easily. Okay, You will understand easily. So first of all, define some of the variables and initialize it. So let's define inf, very large number. You can take anything. We can change the variable also. So we'll take a very large number, something like this, and we'll take n, the number of rows, m, the number of columns, and we'll create a distance matrix. Let's suppose d at nm, and we will initialize it to inf, infinite. Okay, and we'll create a visited matrix. Let's suppose we say v and m, and will initialize to the false. So all the visited matrix value will be false initially. So when we will visit that cells, we'll mark is that true that we have visited it. Then we will set d at 0 0, because we are going to start from this point. So 0 0 is the origin from where we are going to start. We'll create a mean priority queue. Let's suppose we'll call it mean heap, and we'll insert 0 0 0, right? Because x y is the coordinate and this is the time taken. After that, we will define the directions in the step 2. So what are the directions vectors we have given? So directions will take as a 1 0, minus 1 0, 0 1, and 0 minus 1. So we'll go for the, this is for the up, this is for the down, right? Sorry, this is for the down, this is for the up, then this is for the right, and this is for the left. So you can pause this and you can write the in your notes. Then we'll go through the Dijkstra loop. So in the Dijkstra loop, we used to create first the while loop, where we will check if the queue is not empty. Until the queue is not empty, this while loop will continue. So first we will pop the xy that we have given and the current time node with the smallest time, right? So if we will pop it, so we'll have the current one, and from the current position we will go to the next one that we have visited or not visited, right? So the 4 directions that we have given, down, up, right, and left, so all those 4 directions will make a loop of this, that one, and then we'll check the cell we have moved or not. So for that, we'll check if already visited, skip it. If not, then first mark that this is visited now, and then we'll check if xy is destination is equal to n minus 1 cell, means we have reached to the destination, and return the current time. Then we will do what for each cell direction. Let's suppose we'll call it nx and ny, right? Because for each direction we will go inside, right? We'll check if it's within the bounds. Let's calculate the move cost. Let's suppose 1. If this is the condition, x plus y will do 2 is equal to 0, else will do 2. So wait time equal to max, will take max of current time and the move time, right? And which one is the max, that we will update our wait time. So total time to reach, we will take nx and y, and we'll say wait time plus move cost will calculate the total time to reach nx and y. So if the total time is less than d at nx and y, we will update our d and we'll push it to the next one, right? We will push this time into the queue again. So we'll go for the next cell, and from the next cell we will calculate again. We will calculate this etc. After looping, we will return d n minus 1 m minus 1. So these are the steps that we are going to do. I'll show you the code how to implement it, and then we'll final code I will show you. Okay, so why we are using x plus y to checking this value, right? So as you can see, right, where after here, okay, so here we are calculating the move, right? So while calculating the move, right, the cost is equal to 1, then we are writing if x plus y is mod is equal to 2, right? So that is the question we are saying, because the number of moves from 0 0 to xy is x plus y, and so alternative move cost based on the priority to steps the count, right? So so let's understand the code and go through the code. Okay, I'm going to show you in the notepad like how we are going to do, right? So first step, I told you to initialize the variables, right? So to initialize the variables, what you have to do, let's suppose you have row, columns, you will define later. We'll show you the, when we will show you the Leetcode one, right? So the final code I'll show you. Before that, let's suppose you have the row and columns, then we have the distance array, and then we will initialize the distance array, then we'll calculate the initialize the mean heap, and the mean heap we will add 0 0 0 0, right? After that, I told you to create the directions, right? So we'll create the direction like this, right? And then we'll make the Dijkstra run. How we are going to do? So let's suppose we will create a while loop first, and we'll check we will get this x, y, z and time. using the mean heap dot poll, right? So mean heap, we have already added these 3 zeros, so you will get these 3 zeros, right? And then we'll check the condition that I told you, the x boundary condition. Will check, have we reached to the boundary conditions or not. If we reach the boundary condition, we will return the time. Otherwise, over the 4 loops, right, like up, down, left and right, we will calculate nx and ny. Current position will calculate the distance, right, for the nx and ny, so that we can go to the next cell, right? If we will go to the next cell, we have to know the x and y value, right? For that we have to do, and for that we'll check in the grid, right, which steps equal to the time. We'll count the steps from the start. Like we can say, we can also track, we can say we are tracking it, right? We can track manually also, then separately also. And then what we will do, we'll do steps, divide by not divide, we'll take the mod is equal to 0, and we'll check if it is coming 0, right, 1, otherwise 2. Okay, so this is called your cost. It is coming 1 or 2 steps. Either will, the first time it will take what, 1, second time it will take 2, right, like that. And same, we'll calculate the arrival time. We will find the max one, the max between the time calculations and the move at the array, total move time at the array x and y. And then we'll calculate the total time. Arrival time plus cost is called the total time. Now we'll check in the distance. If the distance at nx and y is greater than the total time, it means it is taking more time, right? So we'll update the this time, total time will update now, right? Which one is less, that we will update in the distance array, right? Means because we have to find the fastest one, that is why. Then we'll calculate the mean heap dot add, and so we'll update, add again nx and ny, we'll add the next cell. So starting from the 0 0, we will go to up, down, left, right, where we will go, right, that locations will add here, and the current time we will update. And finally, once this is done, you will return the result, right? I hope you understanding, right, on the Leetcode. So what we have to do, first of all, let me zoom a little bit. Okay, so what I told you, to first initialize these variables, right, that we will do, right? So first we'll initialize the row, like move time that we have given. So from there we'll do dot length, and we'll calculate the move rows. Similarly, we'll calculate the columns like this. Then we'll define the distance array. We'll pass rows and column as a its index m cross n. Then we'll initialize with the max value. So you can define the inf, or you can write the integer or max value, that is also as a infinite values. Okay, so there is some value, right, the boundaries are there, but you can also write the infinite values also. Okay, so you can fill with that value, or you can write integer or max value. You will fill the distance. Okay, next what we will do, we'll create the priority queue to store total time, x, y, and steps, right? So we'll create the priority queue like this, right? And then what we will do, we'll push the priority queue initial steps, right? Means we are going to start from 0 0 0, right? So we'll start. So here what we will do, we'll add also the steps, so we can track the our steps also, right? How many steps we are doing, right? For the first step, it will take 1. Second step, it will take 2. Similarly, again it will reset, and it will start doing the same thing. At the distance at 0 0, we'll do 0, right? We'll initialize this. These are the 4 directions that we have talked about, right? Like up, down, left, right, right? Then we'll check, we'll come to the Dijkstra algorithm loop, and we'll check if PQ is not empty. We'll call it, we'll pull out the that we have pushed into here, right? We have pushed this value into that. So the pushed value will be pull it, and we'll call it as a current, right? So we are in the current one. So from the current, we'll get the time x, y like this. You can get it, right? And the steps you will get at index 3. So at 0 is time, 1 is x, 2 is y, and z is as steps we have at 3, right? So after that, you will calculate, you will check, are we reaching at the destination? If we have reached the row -1, col -1, means we are reached to the bottom down cell, and so we can say return the time. Okay, Now we'll go through the all the directions, right? So you already have calculated x and y. So for the direction at 0, direction at 1, if you'll do plus, right? So you will go to the next coordinate, right? Nx and y. Now you make the boundary conditions, so you cannot go out of the grid, right? And then you just pause this and go through this, okay? Then you calculate the cost. The cost, either it will come 1 or 2 steps, right? Based on the steps, okay? Now the wait time is, if you, so why we are doing this one? So let's suppose the first step we are doing, so we'll get the 1 second. If 2 is coming, right, means we are, if it is dividing, right, sorry, it is divisible is coming, remainder is coming 0, it means the second, this is the second step. Then we are coming to the 3, we'll reset to 1. Like that we have to alternative do, we have to define the cost, and so that you have to write this line of code. Okay, means you have to steps, we have to check the divisibility and assign 1 or 2 cost for the each step. So this is the wait time. So you, how we are going to find the wait time? Wait time will be the max time, right? Max time of the given time and the time that we have given. So what will be the wait time? Either the time that we have calculated, that one, or the that we have tracked one, or either the given time, right? Which one is the max? Which one is the max is called the wait time. Now arrival time you have to calculate. So this is the arrival time. So wait time plus the cost, right? So cost and the wait time, if you will calculate, based on that you have to you will get the arrival time, right? And this arrival time will help you to calculate the time. So how? You will check at the distance value at the given cell, if it is greater than, which one is greater than, right? That we will discard. Let's suppose distance at nx and y is greater than arrival time, means we have to update the distance at that given cell, that arrival time should be less, and so we'll say arrival time will be this. Okay, now we will again, we are at the next cell, right? So next cell, and we have calculated nx, ny, arrival, and you know the steps. For the next step you just do +1, right? Now we will go back to the while loop again, we'll do the same thing, and we'll go to the next cell, and to go to the next cell we need to time x, y, z, we need. We'll check the condition that we have reached or not. Similarly we'll go for all the directions, we'll go and we'll calculate x, y, z, arrival time we'll calculate, and again we'll push into the queue until we'll reach to the last row and column, right? Till that we'll keep doing the same thing. The while loop will keep continuing, that means the etc loop will continue and will continue until we reach to the destination. This is the selected one, right? Once this is done, we will return that. Otherwise finally we'll come here, rows -1, columns -1, and we have already done that, right? So means we out of the loop will come from here, right? We'll return it after reaching the destination. If we are not coming out from there, insert in that, so we'll return the last column at we have, that we will return. Okay, I hope you understand this problem, guys. Let me know in the comment box that you understand the problem or not. Thank you for watching this video. I really appreciate your time, that you have given time to reach here to understand the code. Okay, so let me zoom out. Let's talk about the complexity. If you like this video, and if you don't write the comment, it's fine, but at least like this video, so the YouTube algorithm will promote this video for more users, and it will help me to grow this channel. Okay, because every day I think that why you guys are not liking the video, and if you like this video, it will help me to motivate me to write more better videos for you, right? And so let's understand the time complexity, and please like this video. So the Dijkstra algorithm with priority queue of n cross n nodes, it will take what, how many? So for the priority queue, it will take log of n into m, and for the n cross n nodes, it will take n cross m, right? So you will have that total time complexity like this, right? Now you ping me in the comment box, let me know the space complexity. Thank you for watching this video. Let me know if you have any doubt in the comment box, and if you have, please drop any questions you have in your mind and you are struggling with. please drop in the comment box and let me know that you want the next video on that. Thank you guys. Thank you for watching this video. Your valuable time, but let me know in the comment box if you want more videos breaking down tricky etc variant, and please like, subscribe and hit the bell button for more coding insights, right? So I'll create more videos for you. Thank you for watching this video.